that it wasn't recording the audio, but the video, yes. Okay, this is an operator. Okay, what else is an operator? Okay, let's say this is an operator. It's applied to a function. What else is an operator? This. It's applied to a function. What else is an operator? LOG. It's an operator applied to x, to a function, not just x. It could be anything. So this is an operator applied to a function. Okay, so when does a limit exist? So a limit exists if this is a number. I'll show you a graph in a moment. When x approaches a number from either side. So I'm going to write down first of all, and I'll come back to this and I'll show you how this is written and why. So now we are just talking for another minute about the limit operator. So here's the graph. Again, a function. This is function f of x. And we have somewhere here a point. And what does this say to us? It says that as x approaches a from either side, what do the function values do? The function values from either side approach L. That's the value, the height. So as x approaches a from either side, the function values get closer and closer, closer and closer to L. So this is the limit of f of x as x approaches a from either side is L. So in words, and then I'll come back to write that. In words, limit of f of x as x approaches a from either side, very important, this is very important, from either side, is L. The limit exists if L equals a number. So what are the options then? The limit of f of x as x approaches a from either side can be L, which means the limit exists, can be positive or negative infinity, or it can be d and e. These three options, the limit does not exist. But if it is positive infinity, I cannot write d and e. If it is negative infinity, I cannot write d and e. But all these, the limit does not exist. So when we talk about the limit from either side, both sides have to approach the same number. Does the function have to be defined there? No. So I can have this situation not defined at all, or defined here for a. It doesn't matter. As long as both sides approach the same number, and x approaches a, it does not equal a, for sure. When we say approaches a, we mean it does not equal a. So this is limit of f of x as x approaches a from either side, still L. Still exists. One more example, and I'll come back to show the limit for what we just talked about. This is a problem. because here I can write the limit as x approaches a from the left. A power of negative means values from the left of f of x equals this number, L1, whatever that is. And the limit as x approaches a from the right of f of x equals whatever, that number, L2. Because these two are not the same, then the limit of f of x as x approaches a from either side is d and e. Because this side approaches a value and this side a different value. I don't have a unique value that both sides approach. So this is the left-hand side limit, right-hand side limit. So we can have a left-hand limit, the right-hand limit. And when we are talking about from either side, both sides have to approach the same number. They don't have to equal, and they will never equal because x does not approach a. So it does not equal a. So really, one more time, this notation automatically means x does not equal a. When we say x approaches a, we really mean it. Okay, finally, I can go back and finalize what I didn't on this page. So what does this mean? And we're going to come back to it a lot. It means that the slope of the tangent line at P equals the limit as h approaches 0 from the difference quotient. So we determined the slope of the secant line, and we said the slope of the secant line as h approaches 0 approaches the slope of the tangent line at P. This is what we are going to define, not today, as f prime of x, which is the derivative of the function at any point where the function, I don't want to use the word, but I'll say it is differentiable. We don't know what that means yet. So that's why we need to apply this operator to this function to find the slope of the tangent line at P. Okay, I did not get the chance to show you